Hi everyone, welcome to my channel. Today I am going to continue the topic 2 pointers. So in my earlier video I already discussed that around 15 to 20% of top interview problems would easily be clear to you if you learn these patterns. So this is very important for you to not miss out this video and not miss out learning 2 pointer. 2 pointer helps in reducing time complexity. Second, it helps in reducing the problem data. The data we are working on it reduces them in considerable amount. Like earlier, if you are performing some search and if you would search linearly, then you will have to go through all the sequence. But if you use binary search, in binary search intelligently introduces the concept of 2 pointers, then the data is sorted, so it moves both inward position, and it goes to the mid, it compares, it checks, and if the middle element is smaller than, suppose it is looking for 15 is greater than 11, in that case we know that we have to look for in the right direction. And suppose it is looking for 4, so 4 is lesser than 11, which is the middle element, then it will move backward, like move to the left side, and it will discard the right part of the given data. So this is how 2 pointer helps in reducing data. This was a quick recap of what we learned in the earlier video. Also, one important thing I mentioned, that today I am going to discuss these 3 pointer movements. First is that what I discussed, movement 1, when we when we take pointers from both end and then we try to move inward. So the pointer direction is moving inward, and we move inward until these pointers meet at some point, and then we break, and then we reach to the solution or we don't reach, and we come out of the iterational loop. The second movement is this: suppose there is given an array, in some sort of problems we move like in this direction. We take 2 pointers, we start from the beginning of the array, and then we move forward. So this is second movement. Now coming to the third movement. In third movement, suppose this is array 1, and there would be array 2 as well, and then both of these arrays we take, and then we move our pointers in a particular direction according to the need. So without wasting any time, I am quickly going to discuss all these pointer movements. Let's come to movement 1. Movement 1 I have already discussed. This binary search is one of those examples. But suppose, and today I am going to discuss some problems as well. This See, there are in movement 1 we have two variants. First variant is that array is going to be sorted. In the second variant, array might not be sorted. Okay. So if it is being said that the array is sorted, then you can clearly say that there is possibility of applying binary search and 2 pointer, because both of these algorithms exploit the structured data. So 2 pointer and binary search, if the data is structured, these techniques can directly be applied. So this is an important point to notice. Now the second point, what if array is not sorted? So there are some, let's take when the array is sorted. First, we already discussed a binary search approach. Now we will see the working of 2 pointer when array is sorted. I already told that 2 pointer exploits sorted order of data. This is a revision video. I have already discussed in detail. You can check that out, the whole video. It will start from very end. Suppose we have to reach a target sum which is 19, and right now it will start from very end, and it will check, okay, the sum is coming out to be 24, which is greater than 19. Okay, so you know that the array is sorted, so, and the higher element is going to be at the right end. So to decrease the sum we have to move inward, and we will continue till moving inward until the sum is lesser than 19. So 20 plus 2, which is 22, it is greater than 19, so it will again move inward. 20 plus 18, 2 plus 18 is 20, again it is greater than 19, so we'll keep moving onward until we get a number which is lesser than 19, 17, which is lesser than 19. So we will stop, and now we know that we have to increase the total sum. We will come here and we will increase the left pointer. It is going to be 15 plus 3, 18. again we haven't reached something which is equal, lesser, like greater or equal to. So we will see like it is 4 now. 15 plus 4, 19, and we have reached the value. This is what we are going to return, that okay, we have reached to the solution. Using the approach of two pointer and moving inward, we can solve ample problems like I have already discussed in the above example. Two sum, when array is sorted, we can do three sum. I have already discussed. This is majorly based on what we have done now. Pair sum is similar to what we have done. This is very similar. So these problems can be grouped together. Even all of these can be grouped together. If you look at the solution, count valid pairs, find pair with given sum, these all are quite similar. Squares of sorted array also takes left and right pointers. Compute squares and move pointers. Let's quickly jump to see how we can move forward when array is not sorted, but still we have to compute like these problems. These problems and some of bunch of the related problems you can take and you can solve in a. What I would request every one of you, before I release the next video, please, while you see this video, solve all these problems. You will find the similarity in these, and then you will come to a conclusion that how would you recognize as well that these patterns can be used. Like for example, in the movement one, what you have to look for, you have to see that whether two, some, like some of the pairs you have to use, pairs, triplet. In the threesome you have to compute triplet, okay. And then similarly you can solve foursome as well. Now it would heavily being said that the array is sorted, okay. In the second one, which I am going to tell you, when array is not sorted, you might need to compare left and right end, okay. You might need to go inward. You might have to, you will see that the data you are working on has to reduce every time you are working, and it also big of n time complexity is also a bigger indicator of using two pointer, and when the array is sorted it is a major indication, right? So this is how you are going to find out. Initially you might find it difficult, but if you solve these problems and few more, you will be more confident with this pattern, okay. Now let's, without wasting any time, just jump towards the solving this valid palindrome. In this problem statement, you just have to find whether the given string is a palindrome or not. This example is clearly not a palindrome. Let me first show you how you can recognize whether a string is palindrome or not. Suppose in the palindrome you have a middle in string, or might not be the middle string. The string count can be even or odd number, but you will have something like this, okay. Like if you look at the middle element, left and right side would work as a mirror. Right now you see, if I cut it in the half, you will see last, you compare first and last element, they are same. Last and second last is also the same. So now the solution as well, like how you are going to approach this problem, let's just think for a second. Take a clue how I have discussed the problem. The problem statement itself says how we can solve this problem. If not, let's quickly see. We will initialize left and right pointer. We will take the first element and last element. We will compare if they are same. If they are same, then okay, we will move inward, like left pointer would increment and right pointer would decrement, like this. In the problem you have to do this a lot in if you are using a two pointer, okay. This is an important one. And then you will check whether last and second last is also equal. Last and second last, if they are equal, then you have to move inward as well. Like now again you will move inward, and in this case you see you just have one element, then the loop will break because left and right pointer has to be like this. If suppose there was, this was the example, even then you would have solved it like comparing this comparing this and comparing these both and then breaking the loop. In that case as well, it is going to be a palindrome. This is going to return you true. Now again come to this point. This is not a palindrome, but I'll just tell you, you will start from the left and right end, okay. You will compare these both pointer. In the very first case you see it is not clearly not a pointer. In that case you just simply return false because they are not equal. So this is how you solve the valid palindrome. Tripping rainwater problem as well is all about moving inward, comparing left and right indexes. this is all about comparisons. So now again one word has is added to the keyword. Please add it into the notes that if you have to compare left and right end, then also it is clearly an indicator of two pointer. Okay. Now, dripping rainwater problem is about comparing left and right end. Something more is also included. You can, this is a hard problem, but I have explained it in a way you will find it very easy. Let's quickly think, pause the video and quickly think what you can try with reverse array. Let me explain again. See, in the reverse array as well, you are going to start from left and right end. You will just simply swap it. Instead of comparing, now you have to swap. So again, this can you can do swap left and right elements. This is also an indicator of two pointer. Keep adding to your notes. I have already shared cheat sheets like keywords, pair and triplet, comparison, left and right ends, operations like merging. These I'll discuss whatever is coming. I'll discuss. Then reverse array is simply that you will take both of these index and both of these last and first element, and you will simply swap this. Again the pointer will move inward, and you will see, you will pick these both elements and you will simply swap it. Quickly you can do the swapping. Again you will move inward and you will do the swapping. This is how you will see array is reversed now. Okay, so reverse array is also a very easy problem. If you see the trapping rainwater video, this is similar to trapping rainwater problem. So you can take all these examples, and this is how in just a 10 to barely 10 to 15 minutes video I have already explained how the approach you can use. So please, I would urge all of you not to bug the code, but just to understand the approach and take the approach and solve multiple problems based on particular approach. So this marks to the end. This marks an end of movement one. Now let's quickly see how movement 2 works, or I will make a separate video so that you don't get swell up with the knowledge which I am sharing right now. Let's take movement 2 in the next video. Now keep learning, keep coding. Thank you.